Hello and welcome to session COP223. My name is Varsha Velagapudi. I'm a product manager with Amazon Web Services. Today I'm joined by my colleague Dan Nations, who's a senior developer at AWS. And we will be presenting on how to optimize applications through end user insights. We also have a customer segment today where our customer, Matt Crouch, who's a web architect at Booking.com, will present how they're using these features. In terms of the agenda, we will first talk about why digital experience monitoring is critical for enhancing your end user experience. After that, we'll talk about the features that we have to help you with this need, Amazon CloudWatch Synthetics, and the new feature we launched this week, Amazon CloudWatch RUM. Then we'll hear from Booking.com about their digital experience journey. And then we'll go into a deep dive and do a hands-on demo. So let me start with a quick audience poll. How many people here have a website or application with customers? And how many of you know that it is working right now for your customers as you sit here? That's good. Some other questions to think about is how much downtime have your customers seen recently? How many intermittent issues are your customers seeing? And how you can debug any of that. Now, when you have end user facing issues, these could include like slow page loads or errors. You not only have a bad customer experience, but this also affects your business. There are multiple studies out there that talk about how this affects business metrics. There's one study by Unbounce which says 70% of consumers say that web speed impacts their willingness to purchase. Amazon did a study as well where 1% of their sales was impacted every 100 milliseconds in delay. Now, the customer expectations are only increasing, right? They just want faster performance and an error-free experience. And so it's really important that you have digital experience monitoring to be able to address these issues. So as you're thinking about digital experience monitoring, when ensuring a great customer experience, what are we talking about? Firstly, you'd want to observe what from the customer's perspective. So this would be to spot any intermittent issues and understand when the issues were introduced. Next, you would want to inspect, so identify any performance issues or the sources of it. This becomes all the more critical when you have distributed applications. After that, you would want to respond, so either fix it quickly or roll back, and thereby minimizing your customer impact. So let's look at some of the observability tools we have today with Amazon CloudWatch. Firstly, we have the infrastructure monitoring, where customers can gain complete visibility of across the health of their resources. You can pinpoint outliers using the out-of-the-box service dashboards. You also have continuous auto-discovery of hosts, containers, logs, events, and more. Next, we have the application monitoring, which focuses on analyzing and optimizing distributed applications at scale. Users of application monitoring can troubleshoot transactions across resources. You can connect monitoring telemetry, such as metrics, logs, and traces, and live processes to determine performance bottlenecks. After that, we have digital experience monitoring, which enables customers to connect your user interactions to the application components. In this, we have CloudWatch Synthetics, which ties simulated API and browser tests or degraded experience to backend errors. Then we have the two new features we introduced this week, CloudWatch RUM, which helps you with the end user telemetry, the actual end user telemetry, and CloudWatch Evidently, which helps you validate application choices and helps you with safer launches and experiments. So today's session is focused on Synthetics and RUM. So let's briefly talk about CloudWatch Synthetics. CloudWatch Synthetics allows you to monitor your endpoints every minute 24/7 using lightweight modular Canary scripts. And you can get alerted when there are issues and when your application is not behaving as expected. So you can use CloudWatch Synthetics for availability and latency performance monitoring on your websites and API endpoints. And the cool thing is, you have the outside-in monitoring. It's the client-side monitoring, but it's also connected to your server-side infrastructure through the integration with Service Lens, CloudWatch Service Lens, and AWS X-Ray. And CloudWatch Synthetics acts as a user and makes scheduled health checks, so it's continuous proactive monitoring. And it can alert you on issues even when there's no user traffic. So you're the first one to get notified when there's an issue. Synthetics is easy to get started. We have ready-made blueprints. This include Heartbeat monitoring blueprint, which is a simple loading of a URL, API Canary, where you can stitch multiple HTTP steps together to create an API flow. We also have a web crawl, basic web crawler, which is the broken link checker. And then you can also use Synthetics for complex UI workflows. And you can use the tools that we have, Canary Recorder and GUI Workflow Builder, so you don't have to script all of that. And finally, we have the Canary Blueprint for visual monitoring, which helps you catch any visual degradations in your applications. Once you create the Canary, you can visualize the results and see which ones have failed and also get notified when there's any issues. And when you have to debug, you have the Canary run data. This includes screenshots, logs, which are interactions of the Canary with your application, and HTTP archive format files, which are the individual elements that you're loading for the page. And then you also have the traces that connect the client-side data with the server-side infrastructure. So that was synthetic monitoring, which is great for proactive monitoring, getting alerted before your users see issues. But you still have to understand what your actual end users and how they are impacted. So you have a need for measuring the impact for them. This includes the last mile issues, so if there's something wrong with the connection, and also when there's an issue, how do you quantify that, right? How many users are impacted? And is it more prevalent in some particular location or some particular browser? And then once you have all of this data, how do you correlate back to the application monitoring that you have? So for that, we're introducing Amazon CloudWatch RUM. This is a real user monitoring capability that helps you identify and debug issues in the client side of your web applications. And overall, it allows you to enhance your end user experience. Using CloudWatch RUM, you can view how your applications are performing in near real time across different geolocations, browsers, devices, enabling you to enhance their performance. CloudWatch RUM enables application developers and DevOps engineers to optimize the end user experience and fix these issues, and thereby reducing your mean time to resolution. So in terms of the benefits, firstly, it complements the synthetic data with actual end user telemetry. So you're getting a better picture of your end user experience. And also, now you have the client-side telemetry, so you can use CloudWatch for end-to-end monitoring. And similar to synthetics, the data is also correlated with your server side through, again, integration with AWS X-Ray and CloudWatch Service Lens. This is really powerful because now you can associate every user interaction with how your resources are responding. Then you can actually quantify if there's an issue, how many users are impacted, how many sessions, and you can also get alerted for the same. And for debugging, we have artifacts that help you with fixing the issue. These include error messages, stack traces, user sessions, and X-Ray integration. So now that we talked about, high level what the feature is, let's see how it works. So firstly, you have your web application which loads onto the web browser. These web applications, you can add lightweight web client that we provide, and onto the HTML header of your application, and that's how it collects the telemetry. And so you can use that then to collect navigation events, JavaScript and HTTP errors, and other client-side performance metrics. And CloudWatch RUM provides you the visualization, analyzes the data, and provides it in a streamlined fashion for you to be able to spot anomalies and issues. You also have CloudWatch metrics, which you can use to alarm and get alerted. And you can also optionally send the data to CloudWatch logs for further analysis. There's flexibility in configuration. So you can use sampling in terms of how many sessions you want collected. You can also configure the web pages that you want to understand the performance of. And of course, we talked about tracing, so that's another, just a checkbox to enable. When it comes to the features in CloudWatch RUM, you can visualize these different performance data, which includes page load, HTTP requests, and location-based information. You can also view load time by day, core web vitals, individual components of the page load, including DNS time, initial connection, resources, load time. You can view errors, sessions to recreate the error. And then you can spot anomalies if it comes to different browser versions and monitor for different devices. We also have aggregate user journeys to get a high-level view of how your user and end users are interacting with your application. I can talk more about the feature, but I think it'll be better if you hear from our customer, Booking.com, who's the world's leading digital travel experience provider. For that, we have a recorded segment from Matt Crouch.
Hello, everyone. My name is Matthew Crouch, and I'm a web architect at Booking.com. So I've been working at Booking.com for just over 5 years. And in my time here, I've worked on products such as taxis, car rental, and up until recently, I now work on the Connected Trip. Previous to Booking.com, I worked at BBC Sport for over 6 years, working on their large-scale BBC Live platform. So I'm here today to talk to you about our experiences with synthetic testing and how we're now using AWS CloudWatch RUM to complement it. So before we talk about CloudWatch RUM, I thought it'd be beneficial to you to talk about our cloud journey so far. So Booking.com is split into different organizational units. Each of these organizations has its own infrastructure. So it's a mixture between on-premise data centers and a mixture of different cloud providers. So as you can imagine, we're all in different stages of our cloud journeys. So you've got some of our organizations who are in early stages, who are starting to investigate how we can utilize AWS, to others who are currently in progress and about to complete their migrations. And then our taxi product is fully AWS Cloud Native. So we'll talk a little bit about their infrastructure. So here's a simplified view of our current architecture. So starting on the left-hand side at the edge, we're using Lambda at edge to perform experimentation. So we're able to change origins depending on what variant you're assigned to. So Lambda Edge makes it really easy for us to do experimentation. We're using AWS WAF to protect ourselves from bad actors, so from SQL injections to bot detection. Now, of course, all of our infrastructure is running inside of a virtual private cloud. So our website is in its own private subnet with an ECS Fargate container. It also runs things like Lambda as well. And then we use an application load balancer to expose routes that we want to go public. So to actually get that traffic in, from the public internet. We're using Route 53, and we also have an application load balancer in our public subnet, which then sends traffic back to our private subnets. Now, as you can imagine, we have a lot of data storage requirements at Booking.com. So we use a number of managed database solutions from Amazon, depending on what type of data it is we're storing. And to get that data into the databases, we use things like Kinesis, Data Firehose, or Amazon Simple Queue service to get the data in. So on to synthetics. So synthetics are really, really good, but for me, they only tell part of the story. So usually these tests are run in near perfect conditions, so the network's perfect, and they're run on really powerful hardware. This is not really representative of what our customers will be experiencing in the real world. So this is where RUM comes in. So synthetics and RUM, they really complement each other. So we can use synthetics to set a baseline for our web performance. So we have an initial gauge. And then what we can do is we can use that baseline performance to ensure we're not releasing any regressions in performance into production. We're also using it for visual regression testing. So when changes are made to our design systems or to our application CSS, we're able to quickly verify across a wide range of devices and browsers that we've not introduced any visual regressions. And then where RUM really comes in is we're able to use it to capture anomalies in the real world on real devices, which we're not able to really replicate in a synthetic environment. So Amazon CloudWatch RUM has addressed a number of use cases for us. So the first one being we're able to collect real metrics from real user devices. So we get a lot better of understanding of what's happening with web performance out there in the field. We're also able to use it to collect core web vitals. So core web vitals are very important to us as we feel they're more aligned to the user experience rather than relying on metrics such as page load time, which can be affected by many external factors. As CloudWatch RUM is collecting metrics from customer devices, we're able to easily pinpoint where performance issues are occurring. So whether it's part of our front-end application code or whether it's due to external factors like browser extensions or network proxies. Our website is often embedded within our native applications as well, or in environments that are not browser-based. As CloudWatch RUM is able to collect JavaScript stack traces, we're able to catch obscure errors that might not be caught as part of our normal testing processes. And at Booking.com, we're currently re-platforming a lot of our web estates. So we have a mixture of single-page applications and traditional multi-page applications. CloudWatch RUM gives us the flexibility to integrate seamlessly, regardless of which architecture we are using in our web application. So let's take a look at CloudWatch RUM in action. As I mentioned before, we use Core Web Vitals as our main measure of the user experience. CloudWatch RUM gives us a clear view on how we're performing with largest contentful paint, first input delay, and cumulative layout shift. We're also able to see at specific times during the day whether performance is degrading, and we're also able to see which percentiles our traffic is falling into. As CloudWatch RUM is capturing the entire performance waterfall from when the browser starts to navigate, we're able to identify where performance issues may be lying. So whether that issue is in the browser, or potentially is it something server-side in part of our cloud infrastructure. And as you can imagine, with the millions of customers who are accessing our services, client-side errors are inevitable. So CloudWatch RUM helps us identify client-side errors that may need our attention, with stack tracers giving engineers the precise line where that error occurred. We're also able to have a breakdown of where the error is occurring more, whether it's a desktop, mobile, or a tablet device, and also break down, is it a particular browser that's causing us the issue. So to recap the benefits of CloudWatch RUM, it's really fast to integrate. So we were able to take the JavaScript snippets and embed it within one of our websites and have it deployed and reporting data back in under an hour. With the data that we do collect from CloudWatch RUM, we're able to stream this out via CloudWatch logs. We found this very useful for performing further analysis on the data and using it with our internal reporting. We were also able to put the metrics into long-term storage, so we're able to see over long periods of time how we're doing with web performance. As with every AWS product, the AWS RUM console is very easy to use and has a lot of detailed graphs and statistics that our engineers can use to pinpoint issues, performance issues with their applications. We're also able to integrate with CloudWatch alarms. So these can be used to alert our engineers if there is any performance, if our web performance falls below a certain threshold. So our engineers can address any potential performance issue quickly. And the collection of core web vitals is very important to us. It gives us a better understanding of the overall user experience, and they are now as important as ever, as they can affect your search rankings. Thank you very much for listening to our experiences with CloudWatch RUM and synthetic testing. I'll hand you back to Varsha.
Thank you, Matt. That was so insightful. It's really great to see how they are able to use this for, for a large-scale customer that has millions of customers. Next, we have a hands-on demo by Dan Nations. So, hand it off to you, Dan.
CloudWatch RUM and CloudWatch Synthetics to detect, identify, and reproduce and remediate client-side errors, and also visualize so that they can triage and prioritize issues in their client-side performance telemetry data. So what I'd like to do is run through what we're going to run through is a live demo of how to do that. We're going to see how to use CloudWatch RUM to debug a client-side error in an application that I have here. Then we're going to run through some of that visualization on the client-side performance telemetry data. And then I'll show you how easy it is to instrument your app to send that data to CloudWatch RUM. And then I'm going to show you how also to do that same debugging using CloudWatch Synthetics on that same error. So let me switch over here to our app. So here we have a not-for-profit pet adoption app. It's created through the observability workshop. I highly recommend that if you haven't run through that already. You can see there's cute little pets just waiting to be adopted. So I'm going to choose this one and show you how this works. So and this little puppy here is so cute, as my daughter would say. I'm going to scroll down, hit pay, adoption complete, and it ships in a day. Yay! So let's go back and try a search flow. Search for bunny. Now you can see that those images are hopping into place there, and we'll get to that, take a closer look at that later. In the data, I'm going to take one home, and I'll choose this one here. Scroll down and hit pay again. This time, something went wrong. That is a customer impacting issue. That's a loss of customer trust. Now, as an operator, I want to get to the bottom of this. I simply must. I have questions about how many other customers have seen this? When did this start happening? Where is this happening? And luckily, I've instrumented this app with CloudWatch RUM, so it's been sending telemetry data over to RUM, and we can go take a look at that. So let's jump on over into the CloudWatch console. And if we, in application monitoring, you can now see RUM as a selection there. And that's going to take us to the overview page. And here we have an at-a-glance heads-up display of like how my app is doing. And I have information about the client-side performance and also traffic. And I can see also client-side errors and alarms. Now, if I go here, this is a quick link over to the Errors and Sessions tab inside many of the tabs that we have here. And we'll get to more of these in a moment, but right now we need to stay focused. We're on a mission. We have people waiting to adopt bunnies counting on us. And we're going to scroll down to the timeline of errors here. We can see when an error was introduced, and that lets us detect when an issue started happening. Now we can take action and get back to a good state. We can remediate and undo what we did that may have caused that change or introduced that issue, because we have all the information here that we need to reproduce this issue later. We don't have to have that issue in production in order to reproduce it. And what this also would do is give you it also lets you know when an issue is actually is no longer being seen, which gives you your mean time to recovery. So you can tell when it's stopped happening. Now, let's say we've undid what we did. Let's say we've rolled back on the issue, and now I can come here and see how many users were impacted by that issue. Just very quickly. And also, let me make this a little bigger. I can go to the error itself and drill down into specific errors. And again, we're triaging and prioritizing here because I can see how many errors we've seen, how many customers were impacted. But I want to look at this one here. And I can get some error details, and this is even more information about like where it was seen. So not only do I know when, but I know where, on what devices, what browser the errors are being seen, and also know the version of the browser that it was being seen at. And there's that stack trace that we've been talking about to help you reproduce this issue. Now, as you can see, there are actually a few issues. So we can see even those intermittent issues that don't happen that often. We can actually take a closer look and dive into those. But let's switch on over to the performance tab, so we can have a look at all that rich client-side performance data that we've been talking about here. So there is a lot of data and a lot of ways to slice it. And what we have is these filters at the top. You can filter by browser, or by device, or by country, or combination thereof. And you can even filter by the page. And here we have, again, we're helping to triage and prioritize, and we're able to identify the slowest page. And here's the landing page, so we can filter by that. And let me close that there. So we can see here, looks like a sunrise to me. I don't know if other people see pictures in the data visualization, but tend to see that. So this one's showing when a performance issue may have started happening. You can tell when it started. You can see by the time of day or by day of week. And if I were to change the time window at the top to be the month, the 30 days, I could see the day of the month as well. Perhaps I have issues that are happening on like a weekend or after hours, like maybe my infrastructure is scaling down and that's causing constraints. There's things to help you debug. We have the Web Vitals here that Matt mentioned as well. I'd like to dive a little deeper onto this one. Now, remember the images that were popping into place on the pet adoption app? Well, that's represented here. That's a shift. Makes it really difficult to click on that button. You're kind of jousting around trying to get it before it moves. That's represented here in this client customer performance metric. We also mentioned the waterfall. There's a lot going on when we load a page, and a lot of that data is sent to RUM and visualized here. You can see that I should be spending some time looking at DOM processing time and time to first byte. And if I wanted to do that, I could go up to the request section, and that's going to give me it's going to tell me how long things are taking to load each resource that my page is loading, and it even gives me a breakdown or a list of the longest running resource to help me again triage and prioritize where to spend my time. I could see how long it takes to load like images, documents, API calls, CSS, that sort of thing. Now I want to switch over to user journeys. What we have here is representing the flows that your customers are taking through your website. You can see if that matches up with how you design your website. Are they going where you are expecting them to? In this case, from the landing page to like the Take Me Home page to the Make a Payment page. Now, that's the through traffic. And what we're looking for here is drop-offs, which means that our customers aren't able to or are not navigating through the flows that we were expecting. Like if on a mobile app, let's say if you had people getting to the Take Me Home page but not able to or not going to the Make a Payment page, that could represent an issue. It could be that pay button is actually off the screen outside the viewport and they can't actually click on it. That wouldn't show up on a server-side error. It's not going to show up in your server-side metrics. It's not even going to show up as a client-side error. It's just going to show up as a drop-off, which we can see here. Now, it'd be nice if we could filter and see how our mobile users are navigating, and you can. So right here we can filter by mobile users, and we would see where they're able to navigate to. Now there's otherwise, we have I'd like to mention another service that we just launched, CloudWatch Evidently, which could help you with issues and drop-offs. What it does is it lets you create experiments, and like a common type of experiment would be moving around that pay button to a different place or changing the font size or making it bigger to make it more visible and apparent that that's where you're supposed to go next. And that's sort of those experiments is what you can do using CloudWatch Evidently, which CloudWatch RUM is integrated with. So let's see. This is it's a lot of data. You're probably wondering how long it took to instrument my app in order to send data to all this data to CloudWatch RUM. Anybody have any guesses around months, weeks, days, hours? Less than 2 hours? Yeah. Let's see how fast that is. We go back to our overview screen here. We've got Add App Monitor. And all we need is a name and a domain. 20, so I'll type that in, and we're going to grab the domain from over here. Which as I slowly copy and paste this in. And I'm going to keep everything else the defaults, but that's really all I need to create this app monitor and the code snippet that we'll use. I want the performance telemetry, I want the JavaScript errors, I'm going to keep those checked. You have control and configurability on what you want to send. I'm going to allow cookies, and that's going to send that session information, which is used to power the user journeys page. And the other thing to mention here is that you can send your data also to CloudWatch logs, where you can do further analysis. You can do customized filtering, set up alarms on that. And so let's go down and click Add App Monitor. Now, here's that code snippet. So I'm going to copy that to clipboard, and all I need to do is take this and insert it into the head element. So I'm going to switch over to Cloud9, where my pet adoption site is, and I'm in the layout, CS HTML. And right here, I'm in the HTML head, and this is where I paste my script. It would look a lot like this, what I have here. And it said save and deploy. And then I just sit back and wait for my customers to use my app and send data to CloudWatch RUM for visualization. Let's see. Now, like this switch over. Well, let's see that. So let's switch over to see that same client-side error debugging and CloudWatch syntax. So on this side of things, what you need to know about canaries are that they emulate the customer flow through your application or API for that matter. It's not limited to just websites. You create this customized logic where it acts like a customer. It actually interacts with your website, it makes API calls, and it creates a very stable set of data and metrics that you can alarm on. You can set up anomaly detection on. It's your baseline, it's your steady state. And you can do comparisons with your real user traffic. So if we switch over to Bunny here, what I'd like to do is show you that I have a canary set up to basically run through that same sequence of events where it's clicking on the Take Me Home button, clicking on Pay, and we'll see what happens when it tries to do that. You can see this one's actually failing. On the left here, there's the list of individual canary run failures, and there's a lot of information to help you reproduce that error, which is really handy for catching those intermittent issues that happen every once in a while. You actually have everything you need here to see exactly what would have happened if a customer hit it. The canary itself is broken down into steps. You can see which ones passed, failed, what the error was, very quickly at a glance, where it was and how long each step took. And we link you to screenshots here where you can actually see what the customer would have saw or is seeing at this point in time. You can see that there's the screenshot. It looks exactly like what we saw when we were doing it ourselves. There's other information to help you. We have logs as well. Since we're running on the client, we're also getting the client-side error logged here, as well as anything else you'd like to log to help you debug, and anything else you'd like to do. Because this is a custom script, I can go off and do more diagnostics or trigger other things to happen when I do encounter an issue, to gather up more information to help me as though I were like an operator that just saw this issue. And I can run this as quickly as once a minute. Let's see, to help you further with the debugging side of things, we even have it integrated with X-Ray, which lets you see the traces all the way from the client to your back end through all your dependent services. Which lets you see what happened to individual calls and what happened on the back end, where it went wrong. You can see the customer impact of those calls when they did happen. So let's see now. So with CloudWatch RUM and with CloudWatch Synthetics, you can get a really good picture of how the client-side errors and client-side performance of your application is how it's doing, and be able to detect, identify, reproduce, and remediate any issues that you're seeing there. And with that, I hand it back to Varsha.
Thank you, Dan. That was quite detailed. With that, I would like to recap the session real quick. So first we talked about why digital experience monitoring is critical to ensure your end user's experience is good. Then we talked about the two features that we have, CloudWatch Synthetics and CloudWatch RUM. And then we heard from Booking.com about their digital experience journey. And then finally, we demoed the features CloudWatch RUM and CloudWatch Synthetics. There are some other observability sessions going on this week. If you're interested, you can attend these ones. I'd like to call out that we had the CloudWatch Evidently session, COP222. That should be available for viewing. The other resources, so we have a news blog on CloudWatch RUM, which shows you details about how to get started. There's also the observability workshop that you can get hands-on and try out all of the AWS observability features. And then for pricing, you can go to CloudWatch's pricing page, and there's more information on that. With that, I would like to thank you all for your time today. We hope you'll try out these features and give us feedback. Thank you.